Hello friends, let us discuss a problem on laws of motion in this video. So the system shown in the figure is initially in equilibrium and we have to find the initial acceleration of all the three blocks, that is the two blocks A and B of mass 1 kg each and the third block C of mass 2 kg when the string S is suddenly cut. Okay, so let us again redraw this diagram for the purpose of our reference. This is the first block of mass 1 kg which is connected with the help of a string to another block of mass 1 kg, and this is again connected with the help of a spring to another block of mass 2 kg. Okay, so now we can say that from free body diagram of 2 kg block we can say that the two forces acting on the 2 kg block will be the value of gravity acting downward and the value of spring force, and since 2 kg was initially in equilibrium we can say that the equilibrium condition of 2 kg block requires the value of kx to be equal to 2g. Now this same force of kx will act on 1 kg block. Now just after the instant when the string connecting 1 kg block to the wall it is removed, let us say this string is now removed, at this particular instant, suppose if I consider these two blocks as a single entity or as a single system, we can say that the net force, the net pulling force acting on this system in the downward direction is the value of kx that is already being indicated in the diagram plus the value of gravitational force on 1 kg block. So apart from the value of kx, we can say that 1g will also act, that is m into g will also act on 1 kg block. This is the net pulling force, and this net pulling force divided by the mass of the system, that is this isolated system, the mass of the system, that is 1 plus 1 will give us the value of acceleration of these two blocks. Now the value of kx that we have already found to be equal to 2g. So if we substitute this value, we get the value of acceleration to be equal to 3g by 2, that is 15. So we can say that the acceleration of blocks A and B, blocks A and B that are mentioned, the acceleration of block A and block B will be equal to 15 each. While the initial acceleration of block C will be equal to 0, this can be concluded from the fact that at the instant when this particular string supporting block A is removed, suddenly there is no sudden change in the value of elongation in the spring. So we can say that at this particular instant, the block C will remain in equilibrium initially, since the value of kx will again balance the value of 2g at this instant of time. So the initial acceleration of block C at this instant will be equal to 0. This is our final desired result. Thank you.